This is just a cover page. It gives only the name of our company. Let's go to the next page. So this just gives our introduction only. We have a company named Clarion Power System Limited. We are there since 1998 in collaboration with Fraco, Germany. And we acquired recently one of the oldest manufacturing unit, capacitor manufacturing unit, Madhav Capacitors in Pune. They are the pioneers, and Mr. Tagare, who started this company, he has written many books on the capacitor industry also. So we have taken over that company, and now we have been upgrading and trying to improve the production quality and everything there. So let's go to the next one. So this is the then we start the reactive power. We'll start from the reactive power. So this first slide gives an idea what the reactive power is and how it works in the system. Suppose we have a transformer 100 kVA and we have a motor of 80 kilowatt connected to it, and the motor power factor, say it is 0.8. So along with 80 kilowatt of active power, it is also drawing 60 kVAr of reactive power from the grid. So our purpose is that 60 kVAr, what we are importing from the grid, how we can take care of that. So let's go to the next slide. So here it is in another way, it has shown the active power and the reactive power, and sum of these two, the vector sum is apparent power. These days what is happening is the apparent power is the power which is used for billing purpose. And this is the vector sum of active power and reactive power. The same thing what we discussed earlier in the first slide also. So this third slide is slightly more elaborate. What it does is, suppose we have a load, say 100 kilowatt load, and suppose we are having power factor of 0.7, which is normally not there, but just for the purpose of assumption, we have assumed the power factor is 0.7. Earlier, when the motor's efficiency and everything was not very good, so maybe people were getting even 0.7 long back, but now it's not the case. So 0.7 power factor, suppose it is there. So 100 kilowatt load, active load will have 100 kVAr of reactive power also. The multiplying factor here is 1. So 100 kilowatt also draws 100 kVAr reactive power. It requires 100 kVAr reactive power to run. The induction machines, they run for maintaining the electromagnetic field. They need reactive power, and that is coming from the grid. So for that, we have to have 142 kVA sanction demand. We have to take the demand sanction of 142 kVA. And this is a very, you can say, a large and not workable thing. For just running a load of 100 kilowatt, we should not be requiring 142 kVA. So what we do is, we connect capacitor at the load point. We generate our own reactive power. And suppose we have put a capacitor, and it is shown here, some kVAr is there, 67 kVAr. So we take the power factor point from 0.7 to 0.95. So what happens is, the reactive power, what we are generating, about 67 kVAr, that reduces the import from the grid, and the import is now left only as 33 kVAr. So now what is happening is, 100 kilowatt load, it needs 105 kVA as the, you can say, demand, and 33 kVAr is still imported, but that is also not these days preferred, because people are maintaining a unity power factor because the tariff structures have changed. As per the new KVH tariff structures, what is happening is, we need to maintain power factor close to unity, where the import from the grid, reactive power import from the grid, is 0. So for that, if we are having power factor unity, we don't have to import anything from the grid. We are self-sufficient, and we can manage the show at our end without any support from the grid, reactive power support. And the billing also is now as per the kVAh billing. So this is what the scenario is today. And then what we have is, this is a curve showing power factor. how it is displacement power factor. It is the ratio of kilowatt by kVA, and then true power factor is also taking into account the THD values. So that we have to take the distortion power factor and multiply it with the displacement power factor. Then we get the true power factor. So the harmonics also play a role in getting the true power factor. And normally, so far, the people, the utilities have been taking care of only the displacement power factor, and the harmonics one by one they are taking measures, they are incorporating in the meters, so that the meters are capable of accounting for the total harmonic distortion, and they record the true power factor. But ultimately, it is going to come. So this is, you can say, the multiplying factor. We have to go from one power factor to another power factor. So what is the multiplying factor? That we don't have to calculate every time. So we have the direct tables. We know the kilowatt, and we can find out how much kVAR is needed. And here again, suppose we have to go from one power factor to another power factor, say from 5.1 to 5.2, we have to improve the power factor. So initial, next slide, please. Again, this is a multiplying factor. Again, we go to the next slide. So this is initial demand is also the reactive power is shown. The large vertical, you can say, side of the triangle. And when we improve the power factor, it is reducing. So we get the improvement in the requirement of the power factor. Whatever power factor we have improved, the reactive power input from the grid has reduced. So this is shown in another way here. So let's go to the next one. So what is happening is this one, just before this, one slide before this. Yes, this one. So this average power factor, we all know kWh divided by kVAh, and kVAh is calculated. Earlier, it was kWh plus R kVAh lag scale, and that square root we used to take. But what is happening now? The utilities who are ignoring the leading power factor. So they have realized that leading power factor is equally important, and so they are taking into account the leading power factor also. So R kVAh lead also is measured, and we take the sum of R kVAh lag and R kVAh lead, and then take the square, and then kWh square, and then we calculate the real kVAh. So here what is happening is, suppose our power factor is 0.95 lakh. So we have, say, about 5% shortfall is there in that. And if we are shifting between lag to lead, there is no advantage. Earlier, what was happening is the lead was being ignored. So everybody was maintaining power factor more than unity. They were just going to the leading side. And capacitors people were using as consumables. There were standing orders, purchase orders. Every month, people were just buying capacitors. They didn't want to take any chance. And they were adding capacitors without any requirement. So what was happening is the power factor was leading most of the time in most of the organizations, wherever the power factor incentives were available, unity power factor incentives. So that is what was happening. And because the lead was not being considered, power factor lead. So everybody was on the leading side. So now when the lead is also considered, yes, sir.
I'll just stop you, sir. One query, whether it is the vector sum of R kVH and lag and plus lead, or it is the differential of lag and lead?
Not differential. It is the R kVH is on, suppose you are 0.95 lag. So you are consuming capacitive reactive power from the grid. You are importing reactive power, but it is capacitive reactive power. So what you need is you have to compensate. You have either you have to put capacitors at your end and avoid the input from the grid. But what is happening is, suppose it is going to the leading side, you are still consuming reactive power, but now what is happening is you have put more than required capacitors. So you are importing inductive reactive power from the grid. Whether you import inductive power, reactive power, or you import capacitive reactive power, both are chargeable. Nothing is free now. Earlier, what was happening is the RKVH lag was the only thing which was considered. So if you are crossing unity, everybody was happy to maintain unity. So it is, suppose you have, say, about 5 kVR import of, suppose 100 is the load, 100 kilowatt, 100 kVA, kWh, suppose we say 100 units, and suppose 5 units of you have lag reactive power, 5 units of lead reactive power. So it becomes 5 plus 5, 10. 10 square means 100. So 100 plus this thing, it becomes about 10,100. And suppose your lead is not there, only lag, it was 10,000, only 25. So it has gone by 75 units in that way. So this is how the calculation has changed. So they are measuring the reactive power, lag, as well as lead, and they are calculating as per this. Everything is vector only, basically. That is why we have lag and lead. So earlier what was happening is, first of initially what was there, the reactive power was coming free. People were just maintaining 0.9 power factor and they were getting away with that. And then the utilities thought, because their system was being underutilized, if we have 0.9 power factor, the 10% system remains unutilized. Their installation is for 100%. The currents, people are at 9.9 itself, they draw the full load current. So what was happening is the utilities found that they are not able to utilize, and either they have to improve the power factor at the utilities their end, or they have to tell the consumers that you maintain and we'll give you the incentive. So that is what they started. So then the incentive started. So initially, people were maintaining 0.9 power factor and 10% they were importing. Whatever reactive power demand, 100% was imported. So India, we started with this power factor incentives. And then everybody started maintaining power factor, aiming unity, but they were actually maintaining more than unity. Then they realized that again there is a problem, because everybody, suppose they require 1000 kVR and the actual connected capacitors are maybe 3000 or 5000 even. It was happening that way only. So again, it is making leading to over voltages in the grid and even at the consumer end also. So that way, then the requirement comes for shunt reactor. You have an inductive power requirement when you are overcompensating. So that is what was happening. So now also in India, we have this power factor incentives, KVH billing, but other countries, they continue to have the units are kWh only. And reactive power is still considered free. So what is happening is this free power concept. We always feel that this free power concept has been brought by Kejriwal, but it is not that way. Free power has been always, all along we have been getting free power, but free reactive power.
But sir, what I understand, that different state regulator has different meaning. Sir, it basically, let us say in Odisha, we don't, the regulator, the current tariff order says that we don't charge any leading power factor. Only lagging power factor is being charged. So the calculation in Odisha is minus. So if it is differential, because as an electrical engineering subject, if you see that it is a differential, but if you are saying that meter is being calculating this way, it might be some sense.
You are right. Most of the utilities still continue to overlook leading reactive power. It is only Maharashtra is one of the first states which has elaborate, you can say, regulations. They have come out with this arrangement, and when they started monitoring leading reactive power, they changed all the meters. Everything was, you can say, revamped, and they people were getting 7% incentives earlier. 100%. Everybody was getting almost 7% incentive because nobody wanted to lose this thing, benefit of the power factor incentive. So they were overcompensating. They did not want to take a chance. So when they brought this regulation and they started measuring leading power factor also, the leading RKVH consumption, they started measuring. We got many bills. People came out. One company which was getting 7% incentive, they got 35% penalty. And that was the penalty regime, or that was also changed. It was made, you can say, safer for the consumers. If it was not done, it could have been 70%. 7% incentives as against that 70% penalty.
Okay. Now, if I can see some questions in the chat box.
Yes,
Surinder Singhlaji is saying that no utility is mentioning the lead power factor, and also utility is not billing them the lead power factor. But if you see the Kaji ji jo chat box mein unhone dala hai, he's saying that no, Maharashtra, you have that lead and lagging power factor. So what I can understand from your viewpoint, that different state has different billing methodologies. So some state is charging for lead and lag both. Some states are only charging for lag. Can I take this point in this way, sir?
This is correct as far as present situation is concerned, but this is a transition phase. Already many states have started. You know, Maharashtra, I have told. Andhra recently came out with a circular that they have unblocked the leading measurement, the leading consideration, what was there, it was blocked in the meter. So they have activated it again so that leading also is considered there. In Andhra Pradesh, it has started long back, many months back. So if you go one by one, states are coming out with this leading power factor calculation as per the leading and lagging both combined. It is not only lagging. So one by one, it will be there in all the states. All regulatory commissions, they have authorized them. They have told them you can go. Only thing is these people have to do a lot of work. They have to change all the meters, or they have to change the programming of the meters. Then only they can start working on that. And moreover, they give time to the people also. But Maharashtra gave no time. Immediate. I think they must have initially given some notice and all, though nobody bothered about the notices. Once they started, almost 90% people or more than that were found having leading power factor.
Sir, I have a quick question.
So we cannot take it. Even if some people or some states are not having this provision, it is going to come for sure, and it will be implemented one by one. It is a big exercise. That's why it is taking time.
As a consumer, you cannot be in both mode. Either sometimes you will be in leading mode, sometimes you will be in lagging mode. So you want to say that based on 15-minute cycle, clock cycle, if you are in leading, that will be also added in Maharashtra, and in another cycle, if it is lagging, that will be also added. Accordingly, KVH will be calculated.
Yes, absolutely right. Earlier, it was power factor incentive, and the power factor was considered average monthly power factor. So people were able to maintain unity power factor, even if initially for few days they were having some lagging power factor and all. So they were able to make up by adding more capacitors, more than what is required. So the average was, everybody was able to maintain average unity power factor as an incentive so that they get full power factor incentive, say 7% or 8%. What has happened now is the billing structure has been changed from KWH. Earlier, KWH was the energy unit. The energy is now not KWH. Now the new energy unit is KVAH. You talk of KVAH, means you are taking care of the reactive power. If you don't maintain reactive power installation at your own consumer premises, you are depending on the grid. So you are having, the billing is more. So you will be consuming more units. So this is what has changed now. And what just repeat, you asked something more on that. Just forgot.
No, it's fine. I think Surinder ji and Maheshwar Prasad sir is saying that the Bihar is also on KVH billing. But I'm not sure whether they are charging for both lead and lag. In Odisha, it is only lag. At present, no lead is being charged. Surendraji, you want to say something? You have raised your hand. Kindly unmute yourself and
I just got what you are saying. For sometimes, suppose you have lagging, sometimes you have leading. So both are accountable. So earlier, as I said, you were required to maintain average unity power factor. Now you have to maintain continuously unity power factor. Even if you are not able to maintain for 1 hour, you lose for that 1 hour. Your KVH for that hour is different. Suppose you are maintaining 0.95 for say 10 hours. So your units are more, 5% more for those 10 hours. Earlier, you could manage by making the average unity power factor. So now the KVH billing, you have to be on your toes. 100% time continuously you have to maintain. And it requires full automation. You can't manage it on manual basis also or on fixed basis. And it has to be on both sides. You don't have to have only the capacitors. You have to have inductive compensation also. That's why we have StatComs, SVGs. So that we, as soon as we cross to leading side, it brings it down to the unity again. So we maintain very close to unity.
No, Surendraji, आपका कुछ point है? You want to raise your hand? You want to just unmute yourself, make your question quickly.
So, Mr. Sundar, you can.
As an energy auditor, I mean, it's okay for the lagging factor. But what about the leading factor? When the leading factor is there, how we will judge as an energy auditor whether some window dressing or in case of Harmonics taking into Harmonics into consideration, and if they make a true power factor, but normally they mention only a state power factor, which is always mentioned less than 1. So how as an energy auditor, by seeing the bill, we can see any window dressing?
Yes, sir. From the bill, it will give you the power factor value. It will not tell you how they have calculated it. But they are.
That is our right to ask them.
Yes, you can always.
Or we can, from the bill, we can do that thing because we are working on a basis of a client. And our duty as an energy auditor is there when we know that they are doing some window dressing and putting the bill on a higher. Normally, I have seen in so many bills, even they don't mention sometimes power factor in 2-3 bills. They don't mention and then they mention power factor. Normally, 2-3 bills, they don't mention power factor even.
So power factor, they are sometimes maybe avoiding it, but I don't think they should avoid that. Only thing is the power factor after KVH billing has become irrelevant. The value of the power factor has got no meaning because that is an maybe average power factor. Suppose you have 0.95 to 95 lakh to lead, moving between two sides. For the same,
how as an energy auditor, after seeing the 12 months electricity bills, how I can take care of my client interest that the utility is not doing any manipulation. Whether they are giving me the true factor or a normal factor.
Sir, you have all the rights to ask utility on what basis, what is their basis of calculation. They cannot work in dark. They cannot.
I'll have to answer.
Here I will detect in the bill that, okay, give me the answer. How I can, from the bill, I can detect that thing.
Bill, if it is, I'll just, Baldev sir, मैं उसको answer करना चाहूँगा. In Odisha, what they do, we go, there is a DOM report. If it is a static meter, they are taking the DOM. Then they have all the 5 minutes and 15 minutes block-wise data sheet in which the register data are there, KVH billing and schedule billing. So you pay 500 rupees, you here pay 500 rupees, get the DOM data, and from that DOM data, you can analyze what is the power factor. So normally and also you can have your own software, same meter, you can also download if utility permits. Otherwise, DOM data provision is there. You can ask for DOM data.
So the state during the power factor, easily I can note down by KVH billing. But what my question is that if the leading factor, which are a lot of good chances in nowadays, when the lead factor is there and a harmonics factor comes, then how the utility is addressing that thing and putting the cost on client? Is there any judgment from the bill I can do?
No, sir. Bill will only give you the final figure. It will not give you the calculations how they have done. You have to ask them. They have already circulated. These things are not done without telling the consumers. They are widely circulated. There are regulations months before it comes. They tell you this is the way. That's what I was displaying. How they are calculating the KVAH in Maharashtra. This is their duty. They have to inform you. And you can always question. Suppose you have a doubt on their meter, you have to ask them to recalibrate, or you can check yourself also, or you can put a check meter.
That's good. Aqua check. That is another thing. Aqua check, I can do it. But state highway should write them a letter.
No, write the letter. Before writing a letter, you should know whether they are what they are doing. You have to study their regulations. You have to study their tariff structure. You can't just write anything.
But in the tariff order, there is a provision if the regulation is specifying that the down data can be available. You can
Another sensitive matter which we have addressed is the harmonics. This is also prevailing nowadays, and it is also affecting the overall.
Harmonics, we are coming in the next slide. Harmonics, I have not talked in this slide. This is only talking of the lag and lead. There is a third factor.
Really, but in your first slide, you have taken the harmonics, third harmonics.
No, I'm telling the actual on the
distortion power factor. You have mentioned distortion factor 1 by.
Yes, you are right.
What harmonics you have taken in that?
I am coming to the details of that harmonic, how it is taken.
What is distortion factor?
Distortion factor is the factor which is due to the harmonics. Harmonics have their own reactive power demand.
So distortion factor are the utilities are taking into consideration while converting into KVH?
So far, they are silent on that. Maharashtra came out with
a crucial thing, na? So we as an energy auditor, we should highlight this thing. How we should highlight?
Sir, we are coming. We are just the queries on distortion factor. Actually, harmonics we don't have any right now, and I think we are just we are on the question of the power factor and all. We discuss. We will take up your question. You can write your question. Sir, kindly proceed. And
I have a very small answer for this issue. This if you participate in the tariff process, then you will get the answer. But if you are just writing a letter, you may never get any answer, whether it is a Maharashtra or any other state.
Yes, I appreciate.
So you need to participate in the tariff process, which happens once or twice at 3 or 5 years for the tariff order. So if you participate, utilities will reply you whatever queries, whatever suggestions you are making in the tariff process.
Bhaviji, you are very much right. I have seen. Even for a authentic representation, they always say, "Okay, put a aqua check."
Sir,
they
there
don't
are
give any answer to that.
Sir,
but
there are other ways.
Serious issue. Harmonics and this lead factor is a very serious issue. And
sir, there are other ways. You can get in touch with me separately. Sir, you can get in touch with me separately. This cannot be discussed as it will go out of the track from the main issue that we are discussing.
Sir, it is very simple. These people are very much.
It's not my problem. It is a genuine problem for every energy auditor to take care of their client interest.
It is not a problem. There were distortions which are being corrected. Harmonics.
Sir, I think this discussion should be taken after the presentation is over.
Baldev, you can go ahead with the presentation. Once it is over, we will have a lot of queries and answers.
No, we are going to that only. Now, the next slide was about the harmonics, which we talked about the distortion power factor. So we have one factor is lag, one factor is lead, and the third factor is distortion. So instead of having is vector diagrams on we have a 3-dimensional vector diagram. Instead of 2-dimensional, we have 3-dimensional. So the other D factor is also coming. So we have to calculate the distortion power factor, and then we have to true power factor is the vector combination of P square plus Q square plus D square, D upon this thing of square root. So this is true power factor has to be taken for actually they are very much within their rights to check the KVH demand as per the true power factor, and active, reactive, all these things they are shown here. How we calculate the and the KVH can be calculated if it is calculated as per the leading and also taking into account the distortion. It is you can say they are authorized to do that, and regulatory commissions have no problem if they do it. because distortion has to be removed. And if somebody is not removing, they are well within their rights to punish them. So there is no problem. There is no, you can say, manipulation or anything in that. But problem is they are having problem in changing over to these structures. They need time. They need the meters to be recalibrated. They have to find out the waves, and it is a long process. So it is going to come, but we have to be prepared that we can be asked to pay for distortion. We can be asked to pay for leading power factor. So we cannot avoid that. So as a energy auditor, you should always say that maintain your harmonics within limits, maintain your leading also within limits. So this is...
Sir, I have a little doubt on this.
Yes, sir.
Here the distortion phase current that is expressed as 90° to the plane of reactive and active current.
Yes, yes, yes.
So what's the reason? I mean, we have three types of load: resistive, inductive, and capacitive. So the distortion current has to be in line with either the reactive current or the active current. Why is it taken out of the plane?
No, this is a third dimension basically. You have the two dimensions of active and reactive, and third dimension you can't overlap on that. So it is independent. Reactive this along with the normal fundamental current, the reactive the harmonic currents are also flowing. They have their own reactive power requirement, and that reactive power has to be also accounted for. That is also coming from the grid only. The grid is supplying even the reactive power required for the harmonics to run in the system. So that has to be taken as an independent phase. It is taken as an, you can say, at right angle to that, or whatever they may call it. It has to be a third dimension. It is not two dimensions now. Two dimensions you have already seen. And this is the actual representation. We will get the true power factor only by taking it 90° at that only. It will not come otherwise. You will not get the right figure.
But sir, he has a point. Now, if you say what is harmonics? Higher frequency waveform. Let us I is there and frequency is 50 hertz. Another current is 12 hertz. Let us say 150 hertz.
Okay.
So that I 50 hertz can have also. You want to say that only 50 hertz component is in one plane, then other 150 hertz component are in other dimensions. You want to say that?
So it is having its own RYB phase that is working independently compared to the fundamental. It is not, there is a chart again, maybe there is another one which shows how these things are related with each other. Maybe we'll come to that.
If you have n harmonics, then automatically third harmonics, 9 harmonics, everything have different planes. So
these are also there is a vector diagram. That relation can be always established how it is there. So you see, this is a 50 hertz cycle. Then there is a 150 hertz. How it is, you can say, varying from that. What angle it is there. It can be established. It can be seen on oscilloscopes also. That is there. And it is as per that only.
Okay. So what I if you see the distortion, you are combining all the harmonics and taking into a different plane.
Yes.
Otherwise, it can be any number of planes in which third, fifth, ninth harmonics can play together.
Right.
Okay. Go ahead.
Now we come to this power factor, true power factor, how it can be affected by the harmonics. So there is a chart we have prepared. Suppose your fundamental power factor is 0.996 and your harmonics are around 5%. And distortion power factor here becomes 0.999, almost unity. So your true power factor, there is hardly any change. It just reduces by 0.001. From 996, it comes to 995. So as we go further, the harmonics, as they keep increasing, the distortion power factor keeps on reducing. The multiplying factor is changing, and then the original power factor is same, say 0.996 fundamental. But with 5%, it was 995, 10%, it is 991. And if you go up to say 40%, the 995 becomes 925. It is about 7% difference. So your bill may increase by, if they start taking into account and you are running suppose 40% harmonics, your bill may increase by 7% or something. So this is the effect of only harmonics on the true power factor. We have seen the effect of leading power factor, but we can see the effect of harmonics also. But normally we are never going to have this 40% except maybe in some exceptional cases, some industries may have some problems and issues. And these are not allowed also to have that much of harmonics, because your penalties and other things will not allow you to go there. But normally we have this 10%, 15%, and also marginally it is always affecting. So this is what we discussed about the reactive power. If there are any other questions, we can again discuss maybe during question answer.
We can close the PPT, then after that we can take the points, because there are a lot of queries, and we can take in between.
Okay, sir. So let's go to the now capacitor slide is there. How the MPP capacitor we have shown. This is the latest version of the capacitor. The most advanced capacitors is MPP today. Almost all over the world, more than 90% or almost all requirements are met by MPP capacitors. Earlier, we used to have APP capacitor for low voltage. APP is still there for high voltage, but low voltage, almost universally, it is MPP capacitor. And there are advantages because of that. We have changed over to MPP. I'll just say that 3-4 things. One is that self-healing. Self-healing means suppose there is, for any reason, there is a heavy current into the capacitor. In fact, the capacitor always draws a very heavy current during starting. It is like a short circuit, and then only it stabilizes and becomes normal. But when the self-healing is there in the picture, what is happening is any inrush current, any spot, hot spot is there. So it will melt. The metallization on the film will give way, and the fault will be cleared, and the capacitor will keep on running. So this is the first layer of protection in an MPP capacitor. It is self-protecting. It doesn't require any external means to protect. So this is what happens with the self-healing. Then we have another layer of protection, which is called segmentation. The film is not a one continuous film. It is broken into segments. The fault is generating in some segment or the other. So the fault remains limited in that segment. It doesn't spread throughout. Suppose the segmentation is not there, what will happen is the fault will travel all through and the capacitor will fail very fast. So that is what the segmentation is doing. It is increasing the life of the capacitor. Although very few people are having, I don't think anybody in India is making cell with segmentation. Then the third is overpressure interrupter mechanism. The overpressure interrupter means suppose the gas generation is there. There is a pressure generated inside the capacitor body. Whenever there is a heavy current or inrush current, or during the maybe at the end of the service life. So this pressure is exerted on the lid, and the lid is pushed upwards. The connection physically breaks. So what is happening is it is giving a physical protection. It is like a fuse. So this is also again self-protection. We don't need anything external for protecting the capacitor. So there is another thing now these days. There is an end ring is there, contactless. We don't do soldering now in the capacitors for the end connections. So it is a special ring is there which is fitted onto the ends. And this also helps in making this mechanism, overpressure mechanism, work better. And the losses, whenever the soldering is there, some MFD is lost also. So that is also avoided. So this is the way the best capacitors manufactured today have the features. And these features, because why we have done away with APP is because APP needs external protection. It doesn't provide any self-protection. And the capacitors, basically, they are supposed to work like a fuse. Suppose there is a resonance condition taking place, and the resonance will draw a very, very heavy current. And the capacitor is the thing which is going to take the burden of resonance. Resonance is a, suppose 5th frequency or 7th frequency, it will occur. It's a high frequency current. And capacitor is the item which draws that heavy current. The current, high frequency current, capacitor is drawing all the current. Whenever there is a, you can say, problem, due to harmonics or due to resonance, the capacitor is the first item which fails. It fails because the impedance which is offered by the capacitor is very, very low. So that is why it fails. And in resonance condition, we need that phenomenon. Whenever there is a resonance, there is a heavy current, and there has to be resonance is a self-correcting phenomenon. Suppose one capacitor fails during resonance because of the heavy current, the system will go out of resonance because the balance will be disturbed. So this is required. If capacitor doesn't fail, it may result into a more severe accident. So capacitor failure is not a problem. It should be the norm basically. It is required to fail. And in ATP, what happens is the capacitor doesn't fail because it is designed in a very heavy way. It doesn't have any self-protection. And the system may catch fire. It may have very severe accident also. Because of the unsafe conditions, the ATP capacitors have been, you can say, removed from the system. They are not used these days. So let's go to the next one. So power factor benefits, this is something very preliminary. Everybody knows what is the benefit of power factor correction. These days, it is because the billing is itself kVA. So it is part of the billing structure itself. If the power factor is low, your billing directly increases. Otherwise, the power factor improvement, reactive power system, they don't save any energy except for the losses which are very nominal, not even measurable properly. So these reactive power systems are not for active energy saving. They are for reactive energy saving. And the reactive energy has become the real energy these days. The billing is as per that. So it becomes a very important thing, particularly for energy management professionals. They have to see now the kVH reduction. The kWh reduction is the thing of past now. The losses, even otherwise, earlier we used to put systems just to reduce the losses. But the payback doesn't come with the just minor losses and all. The reactive power system hardly generate ROI for payback of the active power losses. They are being installed, or the people have gone for in a big way. Like you see in other countries, nobody is having power factor correction. People are happy with 0.8 power factor also. They don't find it any ROI impressive with putting power factor correction systems, because there is active power energy, whatever is saved active energy is negligible. The cost of the installation is much high, it doesn't justify that installation. So why we are putting reactive power system is for the reactive energy, and now reactive energy in India is actual energy. So that is why it is very popular here. And other countries, they still are happy without this power factor correction system. 0.8 is considered very good, maybe in US and all. 0.9 is normally in Middle East, 0.9 was also very good. Now they have started realizing, and they have started putting penalties and other things. There are restrictions now in Saudi and all. So they are asking for power factor of 0.95 or something. But we in India are very particular. We want unity only. So this is what the KVA demand reduces, the current reduces, the losses and the life of the system increases. Then you have voltage profile will improve with the power factor improvements. And then the installed system, because your transformers, your other installations, they have the limitation of current. And when you are reducing the current, so your utilization is maximum. You can put more load on the system. Then whatever penalties are associated, they go away. And whatever power factor, that's the last one, right? So now we come to the harmonics. So harmonics are becoming very, very, you can say, critical these days. And the reason is most of our loads are non-linear today. Earlier, we used to have maybe 70% linear loads few decades back, and about 20-30% non-linear load. But now it is just other way around. We have mostly 70% is non-linear and 20-30% is only linear. So we are generating harmonics. And these are creating a lot of issues. We'll discuss the issues also later. And then what we have is what is this non-linear load basically? Non-linear load is, suppose our supply is 50 hertz, a pure sine wave, whatever we get from the utility. But suppose the current drawn by that load is not following the same pattern, if it is not sine wave, it is having a distortion. So that means the load is non-linear, like in a variable frequency drive. So we don't use the full sine wave, we are chopping it off and we are giving to the load. So there we generate these harmonics. And the harmonic non-linear loads today, maximum is VFD is the highest you can say load, which is non-linear load, which is generating the maximum harmonics today. They are the major concern. Then we have UPS, DC drives, VFDs. Next slide, please. DC drives, VFD. Then thyristor controlled heating. Again, here we don't use the full sine wave. We fire it at a maybe different angle for controls, and we are chopping off the voltage. So we have non-linearity here. Then induction furnaces are non-linear, arc furnaces, electronic chokes, lighting. In fact, everything is non-linear today, whether it is fluorescent lamp or what we call CFL, or even the LED. All are non-linear. Then battery charger, then welding controls, rectifiers, SMPS supplies, all these are non-linear, and nothing works without these things today. So most of our loads have become non-linear. Then we will try to understand how the resonance is caused and how these capacitors and systems, they work. Suppose here the non-linear load, we have shown a load which is, say, we are considering non-linear, and then it is represented by a harmonic current source, the non-linear load. And we have parallel connection, power factor connection, capacitors are connected in parallel to the system, the load. And then this is the transformer we have shown here, system impedance. So what is happening is this harmonic current is flowing through the capacitors and also going to the transformer and back to the utilities. So capacitor being a reactive load where the impedance is inversely proportional to MFD value, 1 upon, like we have inductor is 2 pi FL, here is 1 upon 2 pi FC. So it is, as the frequency, harmonic frequencies are very high, so capacitor draws the harmonic current. It offers a very low resistance, impedance, and it is drawing the capacitor. So this is the first item which fails. And then we have these, another problem is this capacitors and in system impedance, they are in parallel. So what is happening is, suppose this value, total capacitance available in the system and the total impedance of the system, including all motors and all, and the system transformer and all, suppose they become equal, there is a resonance, and they may become equal at some frequency. So whatever is that frequency of where it is equal, so that is the resonance frequency. So what we have seen is maybe the resonance we have seen, it is occurring at 5th frequency or 7th frequency many times. And resonance means it is like a short circuit at that frequency. So that, suppose besides normal harmonic, suppose it is a resonance current also flowing, the system will fail very fast. Hello, PPT sharing has gone, I think.
Hello.
Yes, yes.
Can you see it?
No, it has gone to a different page. Okay. I don't know whether people can see it properly. Earlier, it was a better place. You have a different window earlier. Now it has shifted to a very side corner. I don't know whether people are comfortable with that.
Can't see the presentation.
No, we are not comfortable.
Earlier it was
Not visible.
Earlier it
Not
was
visible.
No, we are not
Yes,
receiving
sir.
it now.
Okay,
We are not
please.
receiving the PowerPoint.
And please run in presentation mode F5.
Yes, yes. It is just like one participant it is on.
Please
Not visible, not readable.
use F5 so it will run in presentation mode.
You put in the presentation mode, yes.
Now it's fine.
No.
No,
No,
it's
no,
not
no,
presentation mode.
No, it is not in PPT. It is in PDF. That's why
Oh,
I'm
okay,
only
okay.
able to.
No, you bring it what was there earlier. Now you do it same thing now. I could have shown, but here there is some error is showing here. I was able to do
Sir,
it.
now it is visible.
No, it is same thing.
Back and then come back again.
Just a minute.
Let me see if I can.
Hello, sir. You can make it to full screen. There is an option in the window also to make it full screen. Next to the magnification window, there is a double arrow key. You can press that so that you can become full screen there.
Just a minute, sir. Just a minute.
So I'm also trying. Please admit me. I will try again from my side also.
Just a minute, sir.
Hello. No, Swine, please admit me.
Can you see it, sir? No. You cannot see it at all.
अभी तक तो नहीं आया है.
Still the same.
Let me do it once again.
Now, this Google Meet is the worst thing which we are
Yes.
having.
It should be on Zoom. Zoom.
Zoom is the only thing. If I told him the
Sir, can you see it now?
हाँ अभी आ गया आ
Now
गया.
it is,
yeah, it was there. It came.
now it is okay.
Okay.
म्यूट का बुराई हुआ, मीट का बुराई हुआ तो तुरंत आ गया.
Sir, Meet को बंद कर दीजिए आप, because if you give a rating from 1 to 10, Meet is not even 1 compared to 10 of Zoom.
Yes, sir. Now you can go ahead, please.
Yes, sir. So I was discussing this, how is a parallel combination, C and L, they are parallel, and this is causing the resonance, and resonance means very heavy current. Normal harmonic current itself is a problem, but resonance current is much bigger. So the capacitor fails, and the resonance condition we have to immediately take care, otherwise the system will fail. So you just go back to the same slide. And we can find out where the resonance is taking place, which frequency. So suppose we have the short circuit value in kVA or MVA, and if we divide by the kVR connected in the system, we'll get one figure. It may be close to 5 or 7. So that is the point where the resonance is taking place. And probably without doing any solution, we can have a stop gap solution by changing some capacitor combination. We can increase or decrease, and the resonance will go up. So this is another one, how we normally take care of the problem of resonance and harmonics in the system because of the nonlinear loads. What we do is capacitors are not connected as a plain capacitor. They are connected along with a reactor in series. And this reactor is, normally we have 7% reactor. 7% means suppose 100 kVR is the capacitor, the reactor is 7 kVR. So what it does is, it is doing 3-4 jobs. One is that when the reactor is there, it is limiting the current. Second is, it is shifting the resonance point to a safe place. Suppose it was happening at 7th, it will come somewhere between 3rd and 4th where there is no resonating frequency in the system. So it will be shifting to a safe place. So again, please go back to the same slide.
It's fine.
And and it is the
Not very clear. Not very clear. Please elaborate this.
the third job, which I told 3 jobs. First job is that it is limiting the inrush current. The reactor, when we are having in the system, it will reduce the inrush current, or normal current in the system, it will reduce. It will dampen some of the current.
Reactor is designed with capacitors or what combination?
It is,
Reactor
we can have 7%, 14%, or anything, depending on which harmonic we want to take care. But all will have same thing.
It is designed with capacitor or it is designed with the
It is as per the capacitor. Suppose you have a 100 kVR capacitor and we are using 7% reactor, it will be 7 kVR. And it is connected in series with that. So it is limiting the currents, first thing. Second is, it is shifting the, I'll have the next slide where it will show how the resonance point is shifted. It will shift the resonance point. And the third, the most important job is, it is absorbing the harmonics. Suppose we have designed it for the 5th frequency, 7% means we are tuning L and C combination at 189 Hertz. which is close to fifth frequency. So it will draw fifth harmonic current. And fifth harmonic current, instead of going to the system, some of the current is drawn by this capacitor reactor combination. It is absorbing that current and it is taking it out from the system. So that is how we are mitigating the harmonic current. So all these three jobs are done by these capacitors.
What about voltage harmonics?
Voltage harmonic is the whenever you have a current harmonic generated in the system, it is suppose we have a load. And that load will be having non-linearity. It will draw a non-linear current, and then it will have harmonics, and that harmonic will travel towards the source. And during that process, it is encountering some impedance. So suppose for the load 2, it goes to the LT bus. So LT bus, it will experience some voltage distortion because of this.
When you put a power analyzer, it gives the voltage harmonics also.
Yes, it will give you voltage as well as current harmonics. At every bus, it will show you what is the voltage harmonic. And it is actually normal. Mostly it is created by the current harmonics only. When they travel towards the source, they are getting converted to the voltage distortion.
Baldevji, the biggest problem is that harmonics is a very sensitive issue. Identification of the harmonics is possible, but the designer which are there, still they make it as a black box. And in so many places, the energy auditor who recommend harmonics suppression, they become sorry figure. As you are involved with this capacitor, I mean, the biggest problem is that identification is easy, but designing it a very zero defected harmonic suppression is a big issue. And there the problem comes, the energy auditor's stake will come.
So energy auditor, yes, sir, energy auditor has a role in, basically their purpose is to do energy saving.
No, we do identification. Okay, we do identification. We tell it is the third harmonic, fifth harmonic, seventh harmonic. We tell them this is a voltage harmonic, this is current harmonic. But when it comes to the designer, when you have to design it, you have to put that in system. As far as the power factor is concerned, we are almost certain that okay, you put this and this, the things will improve. But in harmonics, it has been observed, it's still a very dicey factor. And
so it is not a dicey factor. It is a very, very matured area. Nothing is dicey in this thing. You have two systems of harmonic mitigation. We will be coming later to that, but now you have raised, so I'll just tell you. We have one is passive filters, passive mitigation. One is active mitigation. We can do both of them. Normally, we have the fifth and seventh harmonics in the system. So what is happening is, the fifth and that is why we are using 7% reactor, which takes care of fifth as well as seventh harmonic. But it is not the complete solution. 7% will mainly avoid the resonance. The harmonic level before and after doesn't change much. Mostly, no people are not giving any guarantee of harmonic mitigation with 7% reactor. For giving some guarantee, we have to have a better tuning. And tuning at 7% doesn't do much as far as the harmonic mitigation is concerned.
You mean for fifth and seventh harmonics, we have the same design?
It is the same design. We don't have two different filters.
We have the same capacity of the component?
Yes, yes, same filter. Whatever we do for the fifth, it is mainly taking care of the fifth harmonic and all above order harmonics to some extent. Maximum is fifth. It gives low impedance to all the higher order harmonics, not only fifth. So all are reduced to some extent. But we don't design two different filters. We don't design 7% seventh harmonic filter, because if we design a seventh harmonic filter, it will most likely create a resonance at fifth harmonic. It will reduce seventh harmonic, but it will amplify fifth harmonic. So what we do is we design the most significant lowest order harmonic, which is fifth harmonic. So that is why the design is only for the fifth harmonic. And we have mainly fifth and seventh. So this takes care of the seventh also. And even 11, 13 to some extent, all are reduced. So we
have you designed, I mean, as you are very much involved in this, So have you designed any system while we as a consultant visit this harmonic suppression manufacturer, that any test before installation of this harmonic suppressor?
So,
Any testing?
almost every system is designed for this only. 100% systems are made like this. And they are, before, what we do is when we commission the system, we do the testing with and without the system. We show to the customer what is the harmonic before the system is connected and what is the harmonic after the system is connected.
My question is that, is it possible to create a mock harmonics at the time of testing the harmonic suppression filter?
No, mock harmonic you can't create in the load. Whatever actual harmonic is there, we have to work with that only. We are not having.
That is where the difference comes.
Sir, I'll do one. Okay. I think we should continue the presentation. We can take up the question in a later stage because
questions are good, but only thing
these are the routine things here. Most of the people we know. This is not the thing. The challenges which we are facing, we should discuss that thing. I think most of the people know what is harmonics, what is this. This is not the. The question with us is that how we as an energy auditor can do the perfect. Whether it is a question of either doing energy auditing in vis-a-vis with the utility, vis-a-vis the client after that.
So that is what we are doing. The purpose of today's presentation is that
this is all theoretical. This is everywhere available.
Sir, Surinder sir,
your questions will be answered.
Your questions are really relevant.
Move fast.
But kindly be very specific so that we can.
Not specific. It is. I don't know. It is your good name.
Your questions are very.
Request to proceed with the presentation, please.
Yes, sir.
Request to proceed with the presentation, please.
Yes, sir. So what is happening is, in fact, that question came earlier, so I jumped to the next 2-3 slides after that. So this is what we have this harmonics, and we have two types of solutions, passive and active. We'll come to that now later as per the normal process. But now the next slide shows about the harmonics types of harmonics. One is even number, odd number, then zero sequence. So these are the three major harmonics we call. And even numbers are not a problem because normally they cancel themselves in the first half and second half. So they are not in the system. Only odd harmonics are there, third, fifth, seventh onwards. And out of these also, the harmonics which are divisible by 3, third, 9, 15, they are zero sequence harmonics. They are generated by the single phase loads. And we have other harmonics, 5, 7, 11, 13 and all, which are normal odd harmonics. So they have all the same issues. They all create the similar problems, and we have to take care of all of them. But maybe the means are different. So like zero sequence, it adds together and flows through the neutral. So we have an unbalanced current in the neutral. We have also harmonic current also in the neutral for single phase load, like hospitals and some commercial buildings where the single phase loads are there. So there we find the neutrals or even the IT buildings where the single phase loads are there. So there zero sequence harmonic is a challenge. And the neutral is taking the burden of all these harmonics. So what they do is, in all IT installation, you will find they use 5-core cable, 3 core for the phases and 2 cores for the neutral. So these 2 cores, they are made so that it is capable of taking the harmonic. The neutral current could be even twice or more than the phase current. That's why the neutral has to be very heavy. Otherwise, the neutral will burn out. It will have problem. There will be issues. The accidents could be there. So that is why the neutral is made very heavy here. But that is just to, in case there is no mitigation taking place or harmonics are still there, but unbalance is also there. That's why they do it. But otherwise, we are having means to reduce third harmonic also, the zero sequence harmonics. So let's go to the next slide. This is a representation how fundamental is there, and then it is superimposed. Third harmonic is superimposed, and how it is the phase difference and all those things are shown here. So next slide, let us go. So this is the 2 harmonics, I think they have shown, third harmonic and the fifth harmonic and the fundamental. And then the resultant wave is shown in the dotted lines, how the waveform gets distorted. So that is how it will ultimately appear or look like. So let's go to the next one. So this is one question which we took earlier also. I think Singlaji asked. So here we have two harmonics, voltage harmonics and current harmonics. The current harmonics are the ones which are generated by the loads, nonlinear loads, and they are generated at the load and they flow back towards the system. Their direction of flow is from low voltage to medium voltage to high voltage and then to the grid. And during this process, when they are flowing from the load up to the low voltage bus, medium voltage bus, through transformers to high voltage and then to the grid, they are encountering impedance. And at every stage, they get converted into voltage distortion. And every bus will have a voltage harmonics because of this generation of current harmonics only. And what is happening is these harmonics, when they go back to the grid as a voltage distortion, they appear as a voltage harmonic and they come back. The voltage harmonic flows in the other direction. Voltage is connected to all the loads. So that harmonic will be coming from the grid to high voltage, medium voltage, low voltage, then to all the loads and to all the consumers. Whether they are generating harmonics, whether they have non-linear load or not, but the voltage harmonics available in the bus, they have to face all that harmonics. So the purpose is that we have to reduce, mainly we attend the current harmonics and the voltage harmonics get taken care with that itself. So let's go to the next one. So this is what the adverse impacts or effects of the harmonic, because the heating is there, because they are also flowing along with the fundamental current. So they have their I square R losses. Then because all systems, all machinery, electrical, electronic equipment, everything is designed for the fundamental frequency. And these harmonics current frequencies are also flowing along with the fundamental. So the characteristics, performance characteristics change. The equipment, whatever is designed, it doesn't perform as per the design value, or the performance is not there. Then neutral, as I said, the third harmonic, the zero sequence harmonics, they overload the neutral.
Baldev
Yes, sir. Yes,
is
sir.
the unbalancing load also affect the voltage harmonics?
Which one? Please repeat your question.
Unbalancing load. In the
Unbalanced load.
Phase unbalancing. Load unbalancing on the different phases.
So that is what I was talking. Whether it is unbalancing due to any reason or due to single phase loads, it is same thing. So it is generating third harmonic, and that is what is affecting the neutral loading also. So it is created in the system because of the unbalance only. The single phase loads, they create the unbalance, or it could be for any other reason. Suppose you have unbalance, it will create third harmonics.
If there is any correlation, if already because of the unbalancing of load, some voltage, neutral voltage is persisting in the neutral, and it is already some voltage is showing in the neutral, and then the harmonics come. So is there a multiplying factor, or it is a straight line increase? Is there any study on this?
Then a study is there because
I say there is a X neutral voltage and there is a high neutral voltage because of the unbalancing of load.
Neutral
and now the current harmonics act. So is there is the neutral voltage will exponentially increase or linear increase?
it is same thing. You have given the answer also, question also. The problem is the neutral voltage, neutral to earth voltage is because of the third harmonic, the unbalanced since only.
Unbalancing load.
Unbalanced load only.
But directly it is not linked with that.
It is directly linked with that. Harmonics.
Directly unbalancing load. What I am asking is there any correlation between that?
So correlation.
Unbalancing and the third harmonic, current harmonic?
So it is the cause, third harmonic is caused by the unbalanced load only, and the neutral voltage, the voltage across the neutral is depending upon the amount of unbalance only. So whatever is the unbalance, it is a there is no correlation, it is a direct impact of that only.
Direct impact, it is a straight line effect or it is an exponential effect?
No, it is a state only. There is no exponential or anything. It is
Naran sir, I'll advise you kindly finish your PPT and take up the question, because a lot of people are there. There will be a lot of queries are there.
Okay.
Online is 4:30, so kindly close your PPT as soon as possible, so that you can take the Q&A.
Right, sir. Okay, so this is the overloading of the neutral. Then capacitor failures. Capacitor failure means because the harmonic currents, they tend to flow through the capacitors only. They act like a sink for the harmonics. So that is why the capacitor failures are maximum. Whenever there is a capacitor failure, we can infer that there is a harmonic problem in the system. Then thermal protections, they maloperate, because suppose you have designed for a thermal protection to operate, say, at 100 ampere, but it will operate even maybe at 50 ampere, because the heating which is taking place due to the fundamental current is not there, it should not operate. But the harmonic current are also there to heat it. So thermal protections, they maloperate. So we have to see that the harmonics are sort of, they're a problem for a thermal protection. We have to analyze properly. We, at some places, in fact, I also had a problem. We kept on changing the overload relays, thinking that they are not proper, they are duplicate or something like that. But actually, the problem is harmonics. The relay is okay, but it is operating due to the harmonic currents. So that we have to understand when the problems like that come. So next, just please move it forward. Just the same slide, 2-3 points are left out. Then we have erratic operation of control. Similar to the equipments we discussed, the operations are not normal. The things are not designed for harmonic current. So there is a problem in their operational characteristics. Similarly, the controls also are designed for 50 Hertz. So control also will operate. Then we have interference with the communications also. And even the meters, they start misreading. They give erratic readings also because of the harmonics. So let's go to the next one. Have shown the effect of you can see the worst case scenario. There could be a major accident, the fire or explosion or anything can happen if the harmonics are not taken care, and the harmonics, normal harmonics are okay. But if the resonance is taking place, and resonance takes place because of, you can say, people are not using the capacitors properly. Like people keep on putting capacitors without reactors, and they are plain capacitors. They interact with the impedance of the system, and they cause resonance. And that resonance is like a short circuit. And if the resonance is not taken care, it can result into a major accident. Normally, it is as I said earlier, it is a self-correcting phenomenon. Whenever there is a resonance, some capacitor will fail, and the resonance will go away. But suppose we keep on replacing the capacitor, so it will sometime happen into an accident. Or if we are using APP capacitor, it will not fail at all. The installation will run out, but the capacitor will remain safe. So it is not the purpose. The capacitor is like a fuse; it should be allowed to fail, so that we are safe as such. So let's go to the next one. So these are the guidelines, IEEE 519 guidelines, which are the basis of all the regulations of harmonics and power factor and everything. They are basing their, you can say, decisions on this IEEE 519 norms. So if we have normally we are in the range of maybe 11 kV, 22 kV or 33 kV power connections. So there, the voltage harmonics which we have to THD level, we have to maintain is 5%. And similarly, the current harmonics, the next table, that depends upon ISC by IL ratio, short circuit to full load current ratio. Suppose it is normally we are in the range of 20 to 50. This ISC by IL for most of the installations will find it will be between 20 to 50. So we have to maintain TDD of 8%. And here we are not talking of THD, because THD as a current has got no significance. THD could be anything. It could be 50%. It doesn't matter. It may be still okay. But TDD has to be maintained as per the regulations. And THD is with reference to the fundamental current. And the fundamental current, suppose your load is very low, your values could be very, very high. But there is nothing wrong with that. The TDD is with reference to the load current, maximum load current. So here it is important. That's why these people, electricity boards also, they measure the study, power quality study is conducted. The harmonics are measured when the load is almost full, say at least 80%. So THD and TDD are more or less same at that time. But still we calculate the actual TDD value and then we see that whether we are within limits or not. So let's go to the next one. So this is just a calculation how THD value is IH by I1 fundamental. Then THD, it can be calculated like this. And harmonic is I2, I3, I4 all square and then square root we are taking into 100. That is our to THD value. These are directly given by the analyzers. And then the demand distortion, instead of I1, we have IL on the denominator. Okay, let's go to the next one. So these are same thing only THD, TDD and all. And another thing is on the voltage. Suppose we are whenever we are connecting a reactor in series with the capacitor, there is a voltage rise across the capacitor. Suppose we are connecting a 7% reactor, the voltage across the capacitor will be 7% higher. 100 volt will become 107 volts, suppose. So that we have to understand. And that's why we design, whenever the reactor is there, we don't use 440 volt system capacitors. We use the next available higher rating and the safe rating. There is a 480 volt, but that is also not very safe. So 525 volt is the safest rating, which we use. It takes care of even maybe 14% reactor also. So the next is, just let's go to the next one. So this is what initially Singla Saab told about the filters and all. So we have two methods. One is passive, one is active, static system. So normally what you will find maybe in the market, people will give you power factor correction with passive system, APFC system, without guaranteeing any power factor, you can say harmonic mitigation. And they will ask you to put active filter for the harmonics. So the two systems are given, passive for power factor, active for harmonics, but it is actually not required. We can design the passive systems and many times it may be sufficient to do away with active at all. We can do 100% mitigation with passive also. As I said earlier, we have mainly 6 pulse drives and we have mostly 5th and 7th harmonics, which can be taken care by the passive only. And we can only, instead of 189 hertz, 7%, we have to see that some of the steps we tune very close to 250 hertz, so that the maximum harmonic currents are attracted by the capacitor reactor combination. And suppose 20% harmonic, we can bring it down to maybe, if it is only 5th and 7th, we can bring it down to 7-8% easily. There is no need to have any active filter. Only thing is some steps we have to finally tune and put it there, and remaining steps could be with 7%. But if the harmonic spectrum is very odd, and there are maybe other harmonics also, third is also there, 11th, 13th is there, and the harmonic values are also very high. So there we have, maybe we can prefer a hybrid system where passive can do the major job of 5th and 7th, and then whatever is left out, that can be done, fine correction can be done with the active filter. And active, just go back to the last slide. The active is, what we do in passive is we provide a alternative path to the harmonics to be absorbed by the reactor capacitor combination. And that is how we eliminate, we mitigate. But in active, we have a different phenomenon. We inject current, which are 180 degree out of phase with the harmonic current. Suppose we have 250 and we inject a 250 hertz current, but out of phase with the 5th harmonic current. So we kill that harmonics. So in passive, we are absorbing the harmonic in a reactor capacitor, and in active, we are just killing the harmonic. And we can, you can say, configure the active filter for any harmonic. Whatever harmonic we want to cancel, we just inject that at 180 degree out of phase. It can clear any harmonic that way. So let's go to the next one. So this is how the harmonic resonance, I have explained how it occurs. Just earlier slide only, the last one. So here there is a curve. I'll go to the second curve, this one first, or maybe we can have this also. So this is impedance versus harmonics frequencies. So what will happen is the impedance increases initially, takes a maximum value, then it comes down, and the peak point where the impedance is maximum, that is the point of resonance. So this, we have to see at what frequency it is occurring. In this case, we find it is occurring at 7th frequency. So if we draw this curve, so it will indicate where the resonance is taking place. Initially, the impedance is dependent on the inductance of the system, motors and transformers and cables and all those things. But in the second part, it is determined mainly by the capacitors, because capacitors have sensitivity to the frequencies. When the high frequencies are there, the capacitor impedance plays the major role. So it brings down the total impedance. So that is why we get this, where these two are equal, that is the point of resonance. So this point we have to avoid. So here we have shown two loads. Suppose we have a transformer where we have no linear load is connected, only non-linear. So impedance will be very severe. And suppose we have distributed the transformer load, some is linear, some is non-linear, the impedance impact is slightly reduced. It is dampened. So now we come to how this resonance point can be shifted to a safe place. Suppose it is 7th, and 7th harmonic is available in the system. All loads, they have 7th harmonic, non-linear loads. They are mostly 6-pulse rectifier. They will have 7th, 5th. So 7th, there is a resonance and 7th harmonic is there in the system. So that will amplify. So what we do is we connect the reactor which we have shown in series. So that reactor will shift this point somewhere at this place, safe place, either between 3rd, 4th or 2nd, 3rd or something like that. So the resonance will be shifted. So there is no resonance then. So let's go to the next one. So there it is showing the voltage distortion due to this resonance condition. So we have seen the resonance taking place at 7th harmonic. So the distortion of 7th, this volt is maximum here. With the plain capacitor, suppose we are using the plain capacitor, the resonance is there, the voltage distortion is maximum. Suppose we are using 7% detuned reactor, it will come down. But the mitigation is not much. Suppose we are using a tuned reactor, so it will also absorb some harmonics in addition to shifting the resonance point to a safe place. So again, we have a lesser distortion. And suppose we have, say, we design it very perfectly, 5th harmonic, 7th harmonic, 2 filters we give. Normally we don't give because there is a problem, because 7th will amplify 5th. But we can always design in a very, you can say, proper fashion. We work very hard and find out somehow that the resonance is not taking place. Then we can fully remove also the voltage distortion completely. Let's go to the next one. So that impedance I have already explained. It is initially increasing with the frequency, and after attaining resonance point, it again comes down due to the capacitors. Let's go to the next one. So this is how we have seen, like 7% reactor will increase the voltage. We already had seen the formula. So capacitor will experience 7% higher voltage. Then we have to take care of the 10%, say, tolerance level. So if we add that, so we come to 520. So at least 525 volt capacitor should be used. Otherwise, the capacitor will fail. So let's go to the next one. No, the same. Last was there. Some 14%, I think it was shown. The earlier slide. Oh, that is 5.67%, which is a better tuned one. There, the voltage will be not 7%, it is 5.6% more. So it's slightly different. So let's go to the next one then.
Baldev ji, how we decide this detonation ratio? The earlier slide where you put the 5.67 or 7.
That is tuning factor. That's what.
How this calculation?
It is not a calculation. What we are bringing close to now 7% will give you 189 hertz tuning factor. So 189 is very far away from 250. So it will not attract much of the harmonic. It will not mitigate much harmonic. It will not attract. So the remaining harmonics will remain more or less same with 7%. So suppose we take it to 210 hertz, which is 5.69. So then it will attract more harmonics. The harmonic mitigation will be better, and we will get a better result.
Is there any formula, or this is we are taking the next range?
There is a formula. This is derived from the formula only.
What is that?
You will get it in the, maybe I'll share with you. There are in this also, I think somewhere we have shown.
Okay.
Sir, kindly be faster so that you are already 32 slides. You have another slides.
Yes, sir. Yes, sir. Please, next one. No, the earlier first slide we have not seen. This is the active filter technology. The active filter has got many capabilities. It can remove harmonics. It can even improve the power factor. It can generate reactive power. Suppose instead of harmonic frequencies, we generate 50 hertz and we inject into the system either leading or lagging, it will improve the power factor from leading side to lagging, lagging to leading, any side it can do. So it can generate inductive power, it can generate capacitive power. We call it SVG or STATCOM. Then unbalance also, it can be taken care with that. So we have to have these capabilities. For getting these capabilities, we have to design the system as per that. The capacity will be higher, but we can achieve any function. We can remove the flicker also and transients also. Anything can be done. Whatever disturbances are there, they all can be taken by the active filter, but we have to have that much of capacity of the filter so that it can attend to all the problems. So let's go to the next one. So working principle is same as I told. We inject frequencies which are 180 degree out of phase with the harmonic frequency, and then we cancel it out. So this is the, you can say, load current, and this is the current which we have injected, and this is the net current. So it again becomes sinusoidal. So this is another slide which shows how the voltage harmonics can be also directly attended to. The background disturbance, whatever is there in the system, even that sometimes we can take care of. There are some special cases where we have to directly take care of the voltage. So there it is a sensorless control. The voltage itself is acting as a signal. So we can have the this capability in AHF where we can remove the voltage harmonics also directly. Otherwise, the current harmonics, this is normally we remove the current harmonics and it takes care of the voltage indirectly. Let's go to the next one. So this is kWh and kVh tariff. We have shown how they are changing the scenario, the billings and everything. So it's just active energy. Earlier it was, now it is reactive. And the power factor was having limited significance. It was only the incentive was given on power factor, but billing was as per the kWh. And the fixed charges over there for the, you can say, demand and all, that is still continuing. And fuel charges there also. So this is just a billing structure they have shown. Let us go to the next slide where it shows, suppose the power factor is not unity and there is a kVh consumption is there. And this is only lagging consumption they have shown. This was not, leading was not taken into account. So the lagging consumption over a period of 1 year they have seen every month, because power factor not being unity, kWh and kVh will not be equal, and there will be some consumption of reactive energy. So this is the difference is shown between kWh and kVh. The power factor instead of unity, it is a 97974 or 9. It's a very good power factor otherwise. But this also is changing the billing. They had to pay about 11 lakhs extra over a period of 1 year because of not minutely maintaining unity power factor. So this is the impact of power factor maintaining continuously around the year. Otherwise, we lose on the billing. So this is another type of filter. We call it hybrid broadband passive filter. This is normally connected or in series with a VFD. So VFD original harmonics are maybe 40 to 60%. And when we connect, we have two filters here. One is series, one is shunt. Series choke is there and shunt filter is there. Shunt filter takes care of the lower order harmonics and series take care of the higher order harmonic. And that's why we call it hybrid filter. And finally, we have this, say one study is shown 44% harmonics were there before connecting it in series. The supply to VFD is given through this filter. So 44% becomes 6% only. So this is the amount of filtration it can do. So this is at the load itself, we can do it. And this can be done by active filter. And this is because we know mainly it is 5th and 7th 6 pulse VFD. So this is good enough. In fact, we are supplying to ABB along with their VFDs, they are using this filter. So these are just how the components look like. APFC relay, capacitor duty contactor, and then thyristor module is there. Because instead of contactors these days, mostly we are using thyristors because they have many advantages. It is stepless control is there almost. Real-time power factor correction occurs. The inrush current is 0 because we are firing at sign 0 only. So the life of the capacitor is also increased. And we can have any number of switchings. Contactors we have to keep maintaining. After some operations, there is a pitting is there. Sparking it keeps on happening. So we have to do maintenance, replacements and all. Thyristors, we can have thousands of switchings without any problem. So these are also some of the components shown. The capacitors, MPP capacitors, they look like this. Then we have medium voltage and high voltage capacitor and surge protection capacitors. And these are the reactors, high voltage air core reactors we have. Then these are low voltage reactors. And we have a just come back to our reactors only. Yes. Here we use tappings here. Particularly because we don't want to depend on 7%. 7% is regular, you can say very light duty reactor. Everybody is using just their sourcing, putting it there. It may or may not work. Many times we have seen even it is amplifying the harmonics in many steel plants or somewhere we have seen. So 7% is not a universal solution which people just panel builders, they assemble and give, but systems don't work. So we have to keep, you can say close watch. We have to study the system. Particular system has to be seen whether 7% also is working properly or not. And if we have to remove harmonics, we have to see whether we tune it properly for mitigating more harmonics so that the active filter requirement can be reduced. So for that, we have the tappings and we connect the proper tap at site and then we leave it as it is. So this is APFC system, contactor based. The response time is slow, maybe around 1 minute. And then next slide will have the thyristor based system we discussed.
Sir, I have one doubt.
Yes.
Suppose if you are operating on medium voltage soft starters, example 3.3 kV, 6.6 kV.
Okay.
So that soft starters, the firing angle is decided by that customer only.
Correct, correct.
So that time, the voltage amount of magnitude which is going to select, that the remaining portion is going to waste of energy. That waste of energy means that that will convert into form of nonlinear distortion.
Correct.
So for that, how it is going to, it's a kind of harmonic, one type of harmonic.
Yes, yes, yes.
for certain period. Just example for 1 minute, 2 minutes. So that how we can consider as a harmonics, and how what is the procedure to mitigate the harmonic?
Here is same. We suppose although this soft starter is not coming into picture throughout the load, it is only during starting.
Yes, sir.
Starting, if it is not very severe, we can ignore it. If it is a severe problem, if the harmonics are creating issues, then the same filters, whatever we have for passive and active, whether it is full-time or part-time, the job is same. The same filters, whatever harmonics are generated, we conduct the study, we find out which are the harmonics, and then whatever is possible, fifth and seventh, the passive will take care. And suppose there are different harmonics, very we can say odd spectrum is there. The active filter we can tune for that, and that will take it out from the system. Even during starting itself, it will take the job, do its job. So there is no special separate solution. The same solution is there, but it works only during whenever the harmonics are there. But normally harmonics are a permanent phenomenon, except in the soft starter. Suppose so long as the load is there, the harmonics will be there. So we can't have a temporary solution. So long as we are running, the harmonics have to be taken care. It is not like any other, you can say, disturbances in the power quality like voltage dips or swells and all. So they come and go, or transients are there. But harmonics is something which is permanently there. So long as the load is there, harmonics are there. That we have to have a permanent solution. And here your soft starter, maybe it is using for the short time, but the solution is permanent.
Okay, sir. Is it the same procedure for welding loads also?
Welding load also same thing. That also they have harmonic. There, even the power factor also is 0.4 or 0.5, maybe particularly spot welding and all. There we have to design unbalanced compensation, 3 phases. And the harmonic same way we have to do it with the reactors. Or even active filter, suppose the reactors are not sufficient, then we have to put even active also.
Okay, sir. Is there any harmonic mitigation transformers is required for heavy drives, industrial drives, VFDs, soft starters?
No, harmonic mitigation transformer as such is only one transformer is common for harmonic mitigation. That is we call zigzag transformer. That is taking care of the third harmonics mainly. Otherwise, the transformers are not used for harmonic mitigation. It is only active or passive systems. So their transformer means zigzag winding means the arms of the zigzag transformer, they act against each other and they cancel out the third harmonic. So that the design takes care of the third harmonic. Mainly that is for the third harmonic, but not for other harmonics. Other harmonics, we do it with a 14% reactor or with active filter or with harmonic mitigation transformer.
Yes, sir. I heard one of the Japanese expert, I worked under him. And he told,
you please close your presentation, please.
You can close it.
Yes.
No, it is some slide is there. There is one more slide or 1-2 slides.
You can
Yes.
just finish the presentation and then proceed with the question answers.
But let us finish the slides first. Just before that, 2-3 slides are there. You have gone very far away.
These are the photos are basically
this is HT automation. Earlier we used to have only LT automation. Now up to 33 kV vacuum contactors are available, and we can switch on and switch off the capacitors. And vacuum contactor have got special capability, like unlike VCBs. VCBs have limited number of operations, and after that they don't work, they fail. So we cannot do automatic control with the VCB. So the vacuum contactors have been developed for that. They can have maybe 1 lakh operation or 50,000 operations, and we can have automation just like in LT. We can have on HT also, and this is very common these days, particularly in renewable sector. These are being used now. So let's go to the next one. What is the next? This is again SVG, as we told. SVG or AHF, basically it is the same item. Only thing is in SVG, we generate 50 Hertz lagging or leading current and we inject into the system. Instead of physical capacitors and reactors, we are using static system. and we are improving the power factor. And we can control the power factor in both the directions, whether it is leading power factor or lagging power factor, both can be controlled and brought to unity level. So this is another one. In shunt reactors, means these days, these also is becoming very relevant. Many industries, they are facing penalties of leading power factor. The power factor in this industry where we provided this system, the power factor was 0.2 leading. And that was happening during shutdown periods. Normally the power factor was okay, but whichever month they were taking shutdown, the power factor was going very low. So the problem was their line was very long, about 27 kilometers they were getting the supply. The line capacitance was about 1200 kVA. And the load shutdown means there is no load. So the power factor was increasing. So to compensate that, the shunt reactor were given. So this is again automatic indoor panels. This we have given to Abu Dhabi International Airport. So this is, I think this was 3.3 kV automatic capacitor bank. So let's go to the next one. This is 30 MVR 36 kV because we design at a higher voltage because the reactors are there. So we have to design 33 kV system at a higher voltage, maybe 36 up to 40 kV also we design. And there again reactor capacitor fixed type only here. So here this was a study. Here the one case studies now we have 2, 3. So it was furnace was there, and they had power their own generation as well as from utility they were taking the supply. But whenever they wanted to run on their own plant, they were not able to run. The generation was not able to take care of the harmonic load. The voltage distortion was very heavy, and the current harmonics were also there, but because it is a small source, as I said, the current harmonic, when it flows towards the source, it is encountering impedance and it is converted to voltage distortion. And if it is a grid, the impedance is very, very low. It is the voltage harmonics are just 2 to 3%. But if it is an independent standalone system like they had, so there the harmonic current was getting converted into a very high voltage distortion. Here the voltage harmonic is shown here 39%, almost 40% voltage harmonic. So the system, nothing could be run. So there we had given a solution, and furnace, just next slide is the solution. Just go to the next one. So these are the problems they were facing, spurious strippings and failures, burnings, and all those things were happening. So let's go to the next, where we ultimately, and meters were not reading here. The meter stopped reading totally. In 40% harmonics, nothing was visible. So let's go to the next. Here the solutions were given, passive solution on the furnace secondary side, and with the current harmonics were reduced, and that ultimately reduced the voltage harmonics also, and they could run the plant on own generation as well. Let's go to the next one. So this is another study. Again, what we do is we are giving, this is Ultratech cement. Many cement plants they have shown. So just let's go to the next one. Here, what we do is we give a hybrid solution. We try to find out just slightly go up. We'll see the solutions. Active and passive, both. Here HPFC is given, and they are all passive solutions here, I think. Okay. So with the passive itself, 100% power factor as well as harmonics are being controlled here. AHF is also there. In here, the last one, one AHF is also shown. So whatever is not possible with the active, passive, that is done with the active. Okay. So this is another plant where again each transformer, because transformer is a unit, we cannot have a solution, common solution across transformers. Every transformer has to be independently handled, and we have to give a solution, localized solution for each transformer. Let's go to the next one. This is another solar plant. There they had a very peculiar problem. As I said, the reactive energy is chargeable. So these people are generating power and sending it to the grid. And they are not having any system of their own. Now, these days, it has become mandatory. People have to put about 33% reactive power load. Say 100 megawatt plant, they have to have 33.3 MVR reactive power plant in-house in the system. So earlier it was not there. So they consume the reactive energy from the grid. So that is chargeable. They were charging about 28 paise per RKVH. So that is one thing, but that was not being controlled because they were not worried about that. That was manageable. And it was in MP they were charging, but other places they are not even charging anything. But now it has become mandatory. Just last slide only. So what is happening? They had a problem. Their load is about say 60-70 kilowatt, only battery charger, office and all. And their demand was only say 70-80 kVA, but they were recording about 1000 kVA demand because of the poor power factor. The line was about 10 kilometer. And during night time when there is no solar generation, the power factor is very low and leading. So the demand shoots up and the power factor penalty as well as demand charges, about 60-70 lakhs per month, they were paying the penalty. So here one shunt reactor was given and one SVG was given. And the power factor was brought close to unity all 24 hours. And the penalty was removed. So that is how it was done. So I think this was the last slide. Next. Yeah. So this is the actual system is shown. Shunt reactor and SVG is indoor. And all this earthing and everything was shown there. So now we can discuss some questions, whatever people have.
Thank you, Narang Saab. It is quite wonderful presentations, and I hope this session could have been handled in two ways. One, some technical clarity on the harmonics and all, which definitely you answered it well. And the next one, particularly on the case study which you have presented, I think more people will be eager to know about the how it has been saved a lot of money for your end client. Now the questions are open. I will advise each member to write down their question in the chat box. So we can take one by one questions. And in case it's required, they can unmute themselves and I can tell them to unmute themselves and we can take up the questions. And let us make it very small one. And I'll read the questions. I think we did few questions related to power factor and leading power factor and lagging factor. As Narang Saab told, it depends upon the state tariff order, state electricity regulatory commission tariff order. Some states are charging and lagging, some are charging only lagging. So we are not. Then there are few questions on the metering side, and I'll appreciate if Narang Saab can clarify whether conventional meters and how this meter manufacturer are reading lagging and leading, because few clients and few industry perspective that they are not able to relate between leading and lagging power factor. Even if some state where lagging power factor is only being penalized, leading power factor is not considered, the meters are considering both. Is it correct?
As I said, only few utilities have come up with the leading power factor consideration. Others are just following one. After seeing those things, one by one, all utilities are coming out because they have realized that leading power factor is also a problem or maybe a bigger problem than the lagging power factor because the voltage also shoots up with that. So like I said, Andhra, I know they have done it and Maharashtra has done it in a very big way. I think Punjab was also doing it. So everybody is coming out with the regulations. They are activating their meters to read the leading power factor also so that people are not without any, you can say, consideration, indiscriminately capacitors are, because if you don't take care of the leading power factor, people use capacitors indiscriminately as a consumable item, and they create problem for themselves as well as for the utilities. Just to see the bill unity power factor, the maximum benefit, they are not.
Yeah, the question is, sir, whether the meter, they have separate meter for different state, or the meter read both them while showing the power factor.
No, meters are sometimes same. Only thing is they deactivate and activate the provision. The meter has the provision and they are activating it only. And sometimes the meter is not having the provision, they are changing the meter altogether.
Okay. Uday Kumar Sahab was told that power generation unit are maintaining near to unity power factor, however slightly lagging 0.9 power factor, whereas utility plant maintaining lagging power factor, but above the penalty limit, say 0.85 by adding capacitors. Yes, your views on that, when a generator is connected to grid, whether they are being told to generate VAR and so that to help the system.
The generator, when you are saying, that is for captive plants, where they have their own captive power generation also, and they are having their own generation as well as they are having consumption, or they are having input from the grid. So whatever is imported, that is billed as per the normal tariff structure, and whatever they have their own, that is up to them, whether they maintain 0.85 or 9, there is no problem. But whatever the net power imported from the grid, that is taken as per the whatever the state tariff structure is there, it has to be maintained as per that only. And they have to maintain unity power factor for the power which is imported. Sometimes they may not have any generation. So the entire system has to have the reactive power installation where they can maintain unity power factor without any generation of their own. But when their own generation is there, sometimes what they are doing is they are maintaining, because the generators are capable of generating reactive power. You can improve the power factor by excitation also. So they are taking advantage of that. Whatever best, there is a limit to that. But that many people are doing the power factor improvement, they are doing with their generation plant also. That's what these utilities also do. These plants, the turbines and the thermal generators, they are capable of feeding reactive power as well as reactive power, and they use for both the purposes.
And I can see few questions by Santanu Mandalji and Suprakash Swami. Now, whether these, what are the formula you have shown, is it available in any standard guideline is there, or any standards are there where in public domain where this our professional can have those?
Which formula they said?
Particularly the distortion factors and the B formula and whatever the guideline you have said on THD, ITHD and voltage THDs. If you can share the IS or some transaction number, then it can be.
No, there is not what we call TDD, THD and all. There are formulas which are given in the table itself. How the harmonic current is there, fundamental current, ISC, IL values and all those things, they are there. They are standard items. And there are
definitely, but whether is there any standard by any government or CA, or is there any transaction report are available, or any standards are available?
No, you have to see IEEE standards only. IEEE 519 you have to see, and that gives you everything.
But that means you want to say our CA has not adapted those formulas as of now.
No, all over the world, IEEE 519 is the basis for everyone, including India. All utilities, they say we have to. They are saying that everybody should maintain norms as per IEEE 519 only. So this is adopted by everybody. It is undisputed, you can say, regulation. Only thing is the interpretation. People are doing slightly wrong sometimes, but everybody has to follow that IEEE 519.
Okay. Now. Sir, any you want to throw certain light? There is a question by Santosh Mestri ji. You want to throw some light on 4-quadrant reactive power? 4-quadrant reactive power.
That is again whether you are importing or exporting in all the quadrants, there is a reactive power. Whatever import is there, so that has to be taken care. If you are, whatever quadrant you have to have your own reactive power installation and you should meet it. If you are not able to meet, then it is again chargeable only, or it is punishable.
Okay. Now, Ajay Joshi ji and Shiv Kumar Manikam ji actually wanted some more clarification on third harmonics and any suggestion, suitable suggestion to mitigate second order current harmonics. Second order current harmonics, is it there?
Yes, second order is normally not there in the systems, but sometimes we find in many installations. It could be for many reasons. And one of the reasons could be that suppose whatever these 6 pulse or 12 pulse, whatever arms we are having, suppose they are not fully functional. Some of the arm is not working. So they generate very, you can say, unconventional harmonics like second also. So second harmonic, suppose it is there and we are not able to do anything. Passive, normally we don't do it. It is with the active only we can do it easily. Active filter, we can tune it for second also. There is no problem.
And any Ajay Joshi ji questions, any clarification on the third harmonic scent? What do you mean by that?
No, third harmonic, we have two things. One is that 14% reactor. We use 14% reactor to mitigate third harmonic because it is tuned to 133 hertz. So it will absorb third harmonic maximum. And to some extent, all fifth, seventh also will also be absorbed. And then with suppose passive may not be sufficient. So again, what we do is we have active filter also. So there we can tune with the active filter, we can remove whatever is not possible with that passive. We can do it with the active. And then there is a third method of third harmonic removal, that is zigzag transformer. So the transformer is designed to handle third harmonic. It will remove it totally from the system.
Okay. Sir, any Ajay Joshi has again asked your any clarification and on-off harmonics and intra-harmonics.
The intra-harmonics, so far we are not dealing at all. Because it can be designed for that also, but normally what we have been doing, there may be a very special case. Suppose there is a problem coming and intra-harmonic is the only issue. The active filter can be designed for that. There is no problem.
Okay. And Santo Mandal ji has asked, any thumb rule, how much of active filter they consume energy? What is the energy consumption as a thumb rule?
It is 2% or something, 2 to 3%.
2 to 3% of the total power they handle?
The capacity, suppose we have a 500 kVA, 2 to 3% is self-consumption.
Okay. Then Santosh Das ji has also asked, how to take care of over voltage in capacitor design and what is the life of vacuum capacitor in case of ST-FEFC panel? Two questions.
No, what is that first question? Over voltage.
How to take care of over voltage in capacitor design?
Over voltage in capacitor. Over voltage is coming. First of all, the capacitors are designed for a particular voltage, and we design, suppose 440, as I said, we design for 525. But over voltage problem is coming. Suppose over voltage is in the field. Suppose we are in 440 volt system, we have a capacitor, and the voltage itself has shot up. That is why we have taken a very extreme case. Normally 525 volt never will come across the capacitor because we have taken care of 10% tolerance, we have taken care of 7% in reactor also. So there is no question of any over voltage beyond that coming. And again, the capacitor is designed to run at 10% continuously over voltage also. So I don't know, over voltage is never a problem in capacitor if it is designed properly. And what was the second one?
And what is the life of vacuum contactor in case of ST-FEFC panel?
Vacuum contactor, normally 50,000 cycles it can work. And in fact, Ajay Joshi can give better because he is a manufacturer of active this vacuum contactor.
Okay, okay. And what Poonam Dogra ji has asked, what are the penalties? Is any penalty are being imposed for harmonics or any of the state you had any penalty for harmonics?
Yes, yes. Tamil Nadu started long back. They had a penalty on the harmonics, and it was 15%. Suppose your harmonics are not as per IEEE 519, you will be charged 15% of the power bill. And now it has been Maharashtra has started, but they are around 7% or something.
Sir, a question from my side. Without a proper awareness, without any capacity building, when a few companies are manufacturing detuned or active filters, whether you think it is proper to impose, bring regulation on harmonics when a number of countrymen, a lot of agriculture farmers, they don't have access to power supply, whether we are doing the right thing by imposing HAG penalties?
Penalties, nobody does any correction unless there is a penalty. People have been managing. In fact, they were suffering. Their own failures were there. But unless the penalties are there, people are not worried. They keep on replacing the failed items, but they don't take action. So penalties are necessary to keep the people on track. Nobody works. People either they want ROI immediately, they will do it like energy management, energy conservation. Suppose they invest something, if they have a payback, they will do it. In power quality system, there is no payback. So nobody is worried about power quality. So the penalties are not there, nobody will do anything. Penalties are very, very essential, and they have to be very strictly enforced.
Okay. Now, Ajay Joshi ji has again told that arc furnace generates second harmonics, and why our harmonics filter is not grounded. Third harmonics filter are not grounded. Any arc furnace generates second harmonic. Your views?
No, that is practically we have seen that second harmonic we have given a very big solution for arc furnace also. But the generation is there, second harmonic, but it is not going to an extent where it is unmanageable or it is creating any problem. We have not given any second harmonic filter. They don't want any active filter also. Otherwise, we could have given. And third harmonic, we have controlled by 14% reactor in an arc furnace only. We have given 2-3 arc furnace solutions. And third harmonic, we have been able to take care with the 14% reactor. And second harmonic, it is within limits, manageable, so they are not asking for any solution.
But Ajay ji has a different view altogether. What he is writing, that he is basically talking about 33 kV systems, and active filters are not supportive. But perhaps you are saying on 14% reactor that is due to the not filter.
No, 33 kV, we are having 14%
combined bars के लिए बोल रहा है और combined bars के पास नहीं. मैं कहा कार्ड मेल लगा लूं, बोला नहीं combined bars ये मेल नहीं.
Combined bars arrange कर लो.
इस आवाज म्यूट करना
नहीं सर, I have muted.
नहीं, इसमें 33 kV we have the 14% reactors are given at 33 kV only. So whatever, suppose we have a harmonic even at generation at low voltage 440 volt, and if we provide a solution, it is removed all through the system. Suppose we are giving a solution at 33 kV, down the line it will remain as it is. It will not solve any problem. Only above 33 kV towards the grid. The grid will be safe, grid will be saving, benefit will go to the grid. If we are giving at 33 kV, if we are giving at 440 volt, the entire system becomes clean. So we try to give the solution at the point of load itself.
Okay. Okay, I think we can hear from him also. But Srinivasulu Golapalli has also written 30-degree phase shift between two different sources will eliminate 5th and 7th harmonic completely.
We have not heard of that system and we are not using that system.
Okay. Again, any idea again, Srinivasulu ji, 12 pulse phase shift principles. Any idea or lights on 12 pulse phase shift principles?
The 12 pulse generates 11th and 13th harmonic, and that is done so that the harmonic mitigation requirement is less. If we are using 6 pulse, the harmonic generation is very heavy. So we have gone to 12 pulse so that the harmonic, as we go higher, the harmonic content reduces. The percentage is lower. So we use 11th and 13th harmonic filter if it is a problem. Otherwise, 11th, 13th, for 12 pulse, normally people are avoiding any harmonic filter because whatever 11th, 13th are generated, they are not very problematic, or maybe it is within limits of IEEE 519. So they are not worried. And now even 12 pulse is also outdated. People are using 24 pulse systems also.
Okay.
So that harmonic generation itself is avoided in 12 pulse and 24 pulse and all.
Sir, you would like to elaborate what is meant by TDD and PCC? Again,
the PCC means?
PCC for us point of connections or power coupling.
Point of this is Harmonics IEEE 519 says that point of common coupling, PCC. That is the point where more than one consumer is connected. So that is considered as the point where you have to maintain the harmonic levels. Suppose you have a 22 kV supply and you are not the only person. There are many people connected at 22 kV. So they measure the harmonic content at 22 kV. At 22 kV level, you should maintain the harmonics as per IEEE 519. Point of common coupling, where more than one consumer is there.
Okay, Goel Sahab want to send a letter to discuss in front of you all panelists. Goel Sahab, you can write down in the chat box because these are all technical questions, queries. And I understand a lot of knowledgeable and manufacturer also here, particularly the questions put by Ajay Joshi Sahab and others. Definitely we can have similar session from him also. And he has also different viewpoint to put together always. And well, sir, you can put your question in the chat box. We definitely will take it up. We are running short of time. Almost it is 5:24. We are supposed to close by 5, but never mind. These are queries. And JPG, you can send me. Well, sir, you can send me in the JPG. If you have my WhatsApp number, you can send it to me. Definitely. Or if you are an IMP member, you can put in the group. We can discuss it. Now, still few hands are raised. Ajay Joshi Sahab and Mangesh Joshi Sahab, you have any point to make, or you can? Joshi Sahab, you want to share something? You can unmute yourself. I think a lot of queries are from you, and you can briefly introduce yourself, and you can kindly make it short. Kindly introduce yourself, and you can put your questions. If your questions are answered, then you can drop your hand. Mangesh Joshi sir, are you there? You can.
Yeah, I'm here.
Yes, sir, you can introduce
my
and
one
short
question
name.
is,
Yes, please.
yeah,
Sure,
my
sir.
question is that this supply authority, they are implementing the penalty for the harmonics. So many consumers, they are generating the harmonics, and those are affected to the others. So how it is mitigated then?
And, I think what you are telling is the harmonics generated by some consumers, they are people who are not generating, they are also suffering. You mean to say that?
Yeah, correct.
That is the purpose of this harmonic regulation is only that the people who are not generating, the good consumers, they should not suffer because of some few consumers like steel plants and all. They generate harmonics and they dump into the grid, and that converts to voltage harmonic, which comes from the grid, and that is everybody is facing those harmonics. They have to handle those harmonics. But again, why these regulations are there? Because utilities have the responsibility to say that to ensure that they are giving clean supply. They are not feeding any voltage harmonics to anybody. Suppose the voltage harmonics are higher, voltage distortion is higher, so they are punishable. These are two-way penalties. The grid is also punishable if they are not maintaining the voltage standards as per the requirement. So they are more in a problem. There may be 10 consumers who are generating problem, and there are maybe hundreds of consumers who are not generating problem. So the penalties which you have to give to the good consumer is much higher than the penalties they will receive. So if the penalty regime is activated, the utilities will be paying more penalty than the consumers. So they are, you can say, very much concerned. They have to see that nobody is able to get away with the harmonics dumping into the grid. Otherwise, they will have to suffer. So that is the scenario.
Exactly, sir. But rightfully, a lot of question has been answered. But if you see who are the real harmonic generators, definitely for us, all homes are now the generators. Having electric bike in their homes, having a lot of mobile charger, laptop chargers. For us, we at our home started generating harmonics. Now, but when you see about penalty and by state regulator, by few state utilities, but having without any capacity building, harmonics such a vast subject and yet a very complex subject without proper understanding in the graduate level, without having a good capacity building, having good number of manufacturers. I wonder how many capacity or how many manufacturers are there who are manufacturing active filters. We have a lot of APSC panel manufacturers, but we don't have that much of capacity. And if you see now, even Narang Sahab has to also depend upon the different company and to have the component. So it also gives a lot of projection that in India, as an energy auditor or an energy professional, we need to manufacture those products, bring up those capacity building awareness instead of really imposing the penalty. Unless that is done, not done, 2% energy consumption in all filters, and also the scope for having those technology at a very higher cost. For us, these are a lot of questions which need to be answered, whether we are still depend upon or we should bring our, develop our capacity before taking the harmonics into the regulations. So
I think your apprehensions are misplaced. There is nothing like that. There is sufficient capacity in passive as well as active. We are fully self-sufficient to meet any requirement. 100% requirement of active filters, passive filters can be met in-house in India without any imports. There is no problem in that. So there is no problem of capacity as such. Only one problem is coming these days. The CEA, I don't know for what reason they have been asking 33 kV STATCOMs directly. So that is something which will have to be imported. And they are insisting on renewable plants that you go for that instead of automatic 33 kV systems. But that again, it seems to be some lobbies are playing on that. Otherwise, that system is not required. We can manage the conventional systems and it is possible to work. And but sometimes, in fact, the CA people, they had done earlier also some, you can say, certain things which were not desirable. Tamil Nadu, they had imposed penalties. Tamil Nadu government, they were the first to come out with the penalties, harmonic penalties on all voltage levels. So these people, CA came out saying that only 33 kV consumers have to be punished, not below that. So that was something nuisance. It was not required. Everybody, harmonics, our problem at 11 kV, same problem at 22 kV, same problem at 33 kV. So sometimes there are vested interests, some lobbies are there. So there are problems. So now also the capacity problem which you said is coming because of the maybe the wrong regulations being imposed by the government. Otherwise, we have sufficient capacity and this is not required. Certain things which are not required, available only outside. Some people may have collaborations. We also have collaboration. We, in fact, what you said, we don't have, we are importing. We have fully self-sufficient. We have everything in the kitty. We are fully our own manufacturing, active, passive, everything we can meet. So we don't need any outsourcing.
But if I see your presentation, sir, I could see you are importing FDFC relays and
no, we are not
and capacity of duty contractor.
No, that is, we started because Indian, we have some manufacturers, we were having some issues in the working. Capacitors, nobody in India is making that good quality capacitor. But now we are also developing ourselves. We have import from Franco Germany for last 25 years. But now we are trying to develop our own also. So,
sir, any rough idea, if you have any numbers, how many filter manufacturer will be there if your size or similar size in the country, and any ballpark number in any major states.
At least 5, 6 big manufacturers are there.
So do you
Recognized.
think 5 and 6 manufacturers are will be able to
Yeah,
cater
they
to
can
the
meet,
needs of the-
they can meet 100% requirement. There is no problem in that.
And sir, any straight question, whether the cost or whatever is being projected, whether it is right, or you still that you need a lot of demand to cost to come down, because cost is a major factor.
The cost is automatically coming down when the volumes are there. The cost will come down automatically. It doesn't have to be dictated by any regulations or anything. It is only demand and supply. Suppose we are manufacturing say 500 MVR, the cost will come down. Suppose we are manufacturing only 50 MVR, the cost is higher. So it depends on the volume only. So cost is a natural phenomenon. It is not required to be dictated by anybody. Market dictates that.
Sir, whether you think that being 4, 5 or 10 big manufacturers are being there, or component manufacturers, they should extend their hands to all the panel builders or FPC panel builders so that they can supply the technology and component, and the manufacturing can be easier in local place so that repair and maintenance can be tackled easily. You believe in that?
So we are doing that. We are asking all the panel builders, we will give you the design, we will give you the drawings, everything. There is no problem. There is nothing secret in that. They have to buy the components. Suppose we are manufacturing, whatever we are manufacturing, we say you assemble the things. We'll give you the know-how, maintenance, servicing, everything. We are there. So there is no such problem. These are all problems in your mind. There is nothing such in the market actually. So these people, what they do is they try to find out cheaper solutions, and you can say without any design or without anything, and they put up the things, they never work. So it is shortcuts which they apply. Otherwise, there is no.
If you see the MSMEs or if you be small industries, definitely they will be looking for few affordable solutions, not exactly cheaper solutions, affordable solutions. And for us, that is one of the.
All solutions are affordable. These are very, very affordable solutions. People are getting payback within 2 months also. The type of incentives what we have in India, nobody has in the world. The paybacks are very, very attractive. Solutions are all affordable.
Sir, do you think, another query, you are not an organizing member.
You seem to have standard questions without any basis of the ground realities.
Yes, yes. Sir, another question, whether you think any areas where you think IMP and its auditors, the energy professional fraternity can be a lead generator for you, any sort of organization you work on those principles?
Yes, sir, all these consultants, they are the lead generators. They are the people who have to suggest the right solutions. But for that, they have to first understand. I was struggling to talk to your energy managers for a long time, but you remain within your own shell. You don't want to discuss power quality and energy management. And these are certain things which are sometimes acting against each other.
Not exactly, sir. Perhaps this is the first appearance in IMP, but in IMP, let me correct you. We discussed a lot on power quality. We in fact have a very good conference in Bhubaneswar. Dr. Samsar Ali is one of the best known expert in power quality. And you are a manufacturer, but that logic is perhaps is not correct. I would like to correct that. Yes, but regulation is not there, and we are keen to address the policy level advocacy and do write to CA, write to MOP. Any concern you have, you can always write to us. We see that Harmonics, penalty, PFC are currently done, and we should not think that the lobby, we should see anybody, any certificate company to work on a lobby. And but in the same time, as a consent keeper to the nations on energy matter, we expect that a lot of capacity building has to happen, and so that it can be taken forward, because finally it has to be affordable.
Capacity is required. Suppose the renewable are coming particularly in a very big way, the capacity is going to maybe fall short also. But everybody is geared up to improve. There is no problem. Let the demand come. Everybody is ready for that.
Okay. No, sir, it is very, very wonderful that you have shared. And I think there is a question also.
Baldevji.
Yes, sir.
Can you take to that slide where you have shown the 40% harmonics?
That was just to indicate how.
I would like to know approximately
7%. Your harmonics, your power factor, true power factor will go down by about 7% if you have 40%.
No, can you take that slide? Can you show that slide?
No, it is just numbers given in the. I'm telling you. 996 goes to 91.
Sir, we are already running short of time.
There are three issues.
No, there is same thing. In 996 to 91 it comes.
You provide complete solution. If any harmonics identification, we send you that report.
Yes, sir.
You will give a complete solution with supply.
Yes, sir. In fact, we will suppose you give us any study, whether you conduct or anybody conducts. If we have a study, we can design 100% solution, and whatever we are conducting the study, it is end to end. We conduct the study, or if the study is already there, we give the solution and full guarantee is taken.
Approximately in a power factor improvement, we approximately take a cost factor that okay, this must be the cost. Can we take some thumb rule approximately for this particular third harmonics or this total harmonics? This is the cost.
There's nothing like that. Every solution, it is all things are
approx cost.
No, sir, nothing. There is nothing standard.
Can you send some study where you're saying that it is the payback period is 3 months?
Please listen to me. You are talking about something. You want to make it standardized. It is not a standard product. It is not a switchgear. It is a customized item. Every solution is different. No two solutions are same. Everything has to be
agree.
And every solution has to be specifically designed and guaranteed. You can't have any thumb rules. You can't have any standards. It should not be done.
A range.
Whoever has done it, they have failed. They have created more problems than solutions.
No, this used to be happen in the power factor also, but then a range of prices comes. That is how it has picked up. Earlier, when if you remember 20 years back, the same black box was there for a power factor also. But then a range comes. Approximately range.
So now, earlier also there was no black box. Now also there is no black box.
You are creating a black box?
There is no black box.
No. We will not discuss in that line. But I can take it. Surinderji, from your viewpoint. And
no, you just tell me the cost of that 40% suppression. What is the cost?
Sir, it is not
40% suppression. What is the cost?
It is not that straight away, sir. 40% correction. We have to find out many. We have to conduct full study. Find out what.
Your slide. You have shown that your match with 132.
We are not discussing cost here. This is a technical seminar. Now we are talking of technical seminar, not talking about cost. And cost,
we can always discuss one-to-one.
Cost is individual thing. It is one-to-one.
This is a technical. Let me handle it. This is a technical seminar. Your viewpoint is really worthy to the extent that we are not having that much of capacity or knowledge, perhaps, for which a strategic cost or a per KVR cost or a per APC panel cost or active filter cost cannot be determined. Yes, definitely. Now, when the loads are becoming similar and when the loads are almost becoming similar, there are a lot of opportunities coming up where to standardize and certain cost, but it will perhaps only take a lot of times. And definitely the component cost will come down with that. That point is worthy. But let us not discuss the cost at this technical seminar.
I don't know.
Always because Mr. Narang will not be comfortable and he needs the data to analyze and perhaps with the.
I don't understand what you are talking. These are things which have to be studied individually. Every site is different. Every situation is different. Every load is different. The requirements are different. What you need, what you don't need. We have to see many factors. It is not just standardized cost anything. There are standardized. We give you can say we are giving budgetary cost for everything. But this is not the forum to give the cost. We are not discussing here the cost. There is a you give us everything. You want a particular cost. You give us the solution. You give us the problem. We'll give you the budgetary cost also. That is not a big thing. It is the simplest thing to do. But this is not the right time to ask for the cost and all those things.
Agreed, Narang Sahab, agreed. Now, Mohammed Sijaz Sahab has written something, and
Okay, sir. Thank you. Bye.
a lot of queries in this chat box, and really, I'm quite
Yes,
thankful to
Baldev.
Nayan
Baldev,
sir.
we will come in touch with you, Baldevji.
Yes, sir.
Baldevji, I'll
You are
send you
welcome.
my reports and then we will interact directly. Okay.
You are welcome, sir.
Thank you
And
very
our
much
good-
for giving this. Thank you. Thank you very much.
Yes.
And lastly, we are coming to the close of the webinar. And really, Naran Sahab, it is a very wonderful technical seminar, and with the way you presented, the way you approached, and we are really grateful to you. And from on behalf of IMP, it is our duty to connect each other, and there are few takeaways that we need to build up the capacity. We need to write to appropriate forum for having good resolutions, having good policy in place, and looking into the IEEE transactions and the CA grid code and CA metering regulations. And we perhaps wherever the approach is that, definitely Harmonics is going to be a good subject. And if you really, what Naran Sahab told, if you install Harmonics, it will be payback period will be within 1 year. Lot of unwanted nuisance tripping will go away. You can save lot of energy. Rolling mill, lot of Harmonics are being generated. There is a huge potential of energy saving. So, and we have showcased all the industries. Even our stalwarts has worked, designed all this filter, which has been really implemented at ground level. And both active as well as passive filter, IMPs and their stalwarts have already worked. And the way, and definitely one of the takeaways that we need to connect with Narang Sahab so that he becomes an organized member and we can connect each other and we can become a lead generator. So the capacity building will happen and he can offer case-to-case basis his solutions. And we are quite happy and I'd like to thank Narang Sahab, and I'd like to thank all the participants. We got almost 100 registrations, almost 77 participants are there at the time. And definitely everybody who are not member of IMP can join us. We'll be sending you the live membership link, and you can become a member of IMP. And in our WhatsApp group, we discussed all this report, all these transactions, all these issues, and we can get a lot of clarification to your queries in our WhatsApp group also. So with this, I'd like to thank Narang Sahab once again, and let us bring a logical conclusion to this webinar. With this, I thank you and meet once again.
Okay, thank you, sir. Thank you from my side also. Thank IMB for giving me chance.
Thank you, sir.
Okay, thank you.
Yes.